Okay, class, we're about to start section 9.1, part 1, simplifying radical expressions. Objective 1, introduction and notation. Inverse relationship between roots and powers. Does the nth root of a is equal to b can be written as, we could write this as a to the 1 over n power is equal to b, or we could write this as a is equal to b to the n power. N is called the index, and the symbol square root is called a radical sign. This is just a radical sign. The notation blank is shorthand for the square root of x. So if we do this here, this is assumed to be a square root. This index of 2 is automatically assumed to be there when you don't see that index. A is called the radicand. Now, it says evaluate the radical, working by hand where possible. The cube root of 64, we know is 4, because 4 times 4 times 4 is 64. The fifth root of 32 is 2. Now we come here to the sixth root of 1 million, which should give us 10, because 10 times itself 6 times will give us 1 million. Now we have the fifth root of 40. Now this would actually end up becoming a decimal, because there isn't 5 digits except for 1 multiplied by itself in 40. There is no perfect fifth root. So we need to take a calculator and take the fifth root of 40. And this will give us approximately 2.09. Now we have the cube root of a negative 125, which will give us negative 5. And then we come here to the fourth root of a negative 81. Now, with the fourth root of a negative 81, whenever we have an even index, we know that we're going to get an I value. And then the fourth root of 81 we know is 3. So this answer here would be 3i. Now we come here. The seventh root of a negative 64. We do not have a perfect seventh root of a negative 64. So we need to put that in our calculator. So you would put this in your calculator to get your answer. And your answer here would be an approximately negative 1.81. And then last but not least is h. We have the sixth root of a negative 64, which we know since this index is even, we will have I. And then the sixth root of 64 we know would be 2. So our final answer here would be 2i. Now we scroll down here to example 2. It says rewrite each radical expression using fractional exponents. Give the simplified form of both the radical and exponential expressions. Now the 7th root of x to the 4th, the simplified radical would be the same thing. Now as you see here, it's jumping, so I'm going to have to fill this out and put it in completed. So now we want to get the simplified exponent. This will become x to the 4/7 power. And we know this cannot be simplified, so we're done. Now we come here. We come to the 8th root of a to the 6th power. Okay, first of all, we cannot simplify. Well, I guess we can technically simplify this radical. 8 and 6 both has 2 in common. So this would be the 4th root of a to the 3rd power. And that will be the simplified radical. The simplified exponent will be a to the 3/4 power. Now we scroll down here, b to the 2/5. We'll write this as a simplified radical. It'll be the 5th root of b squared. Now we will write this as an exponent, simplified exponent. It'll still be b to the 2/5. Now if we look here, x to the 3/6 is the same thing as x to the 1/2, which is considered to be the square root of x. And then we know x to the 1/2 is the simplified exponent. Now we have the square root of x to the 8th power. We know the square root of x to the 8th power will be x to the 4th. And then the simplified exponent still would be x to the 4th. Now we come here, the cube root of a to the 15th. We could simplify both of these by 3, or we could just say the cube root of a to the 15th is a to the 5th. And then we know the simplified exponent would be still a to the 5th. Now, we have the 8th root of n to the 24th, which is n to the 3rd. And then our simplified exponent would be n to the 3rd. Now we come here to these last two problems. We have 4x to the 2nd to the 3/8 power. So this will end up being the 8th root of 4x plus 2 in parentheses cubed. And then our exponent would still be 4x plus 2 to the 3/8 power. Now we come here. Now, this is the cube root of 7n to the 7n plus 3. It'll still say the cube root of 7n plus 3. Now for the simplified exponent, it'll be 7n plus 3 in parentheses to the 1/3 power. And that is it for that page. Now we come here. It says objective 2, arithmetic properties for radicals. Since radical expressions can be rewritten as exponential expressions, they must share the same properties. Now we have ab to the n power is equal to a to the n, b to the n. So the radical form of this would be the 1 over, hold on, let me pause this for 1 second. The index would be 1 over n, and on the inside here would be a times b. That would be the radical form. It says the quotient. We have a over b to the n power, which is a to the n over b to the n. And this is the same thing as 1 over n, and it'll be a over b under the radical. Now it says sum. It says cannot apply exponents directly to the terms. So, okay class, I made a slight error here. They did not want me to change it from exponential form to radical form from this here. What they wanted us to do was this here. If this was originally written as the nth root of AB, this can be rewritten as the nth root of A times the nth root of B. This is what they were actually looking for. Now over here as well, I can cross that out. Okay, we have A divided by B, both taken to the n power. Now if we took the nth root of A over B, that's the same thing as the nth root of A all over the nth root of B. Now we come down here to the sum. We have A plus B to the n cannot apply exponents directly to the terms. Now we took the nth root of A plus B. It's the same thing. We cannot apply exponents directly to the terms. And then it's the same thing with the difference. We cannot apply this exponents to the individual terms, directly to the terms. Okay, now with example 3, it says simplify or explain why it cannot be simplified. First of all, the square root of 25 we know is 5. The square root of x to the 6 is x to the 3rd. Now we go to B. Now remember, this cannot be simplified. You cannot take the square root of the individual terms. So you could put cannot take the square root of each individual term. Okay, now we come down here to C. We have the cube root of x to the 6 over 8, which is the same thing as the cube root of x to the 6, all over the cube root of 8. Cube root of x to the 6 is x squared. Cube root of 8 is 2. Now we come here, and this right here, D has the same answer as B. So you'll put cannot take the square root or the cube root of each individual term.